everyone, and welcome to this video going over lesson 23.2, the law of cosines. In the last video, we talked about the law of sines, which is a method for finding missing sides and angles of non-right triangles. But in order to use the law of sines, we need to have a complete opposite side and opposite angle pair. If we don't have that, then our backup option is the law of cosines. The law of cosines says that if we have a non-right triangle, then c squared equals a squared plus b squared minus 2ab cosine of c. Notice how the side we start with, we also end with using that angle. So if we start with side c, we end with the cosine of angle c. Now there's different variations of this. I don't have to start with side c. I could start with side B, and if I start with side B, then I would do a squared plus c squared instead, minus 2 times a times c, and then cosine of b, because the letter I start with has to be the letter I end with. And I also could start with side A. So I would have a squared equals b squared plus c squared minus 2 times b times c, cosine of angle A. So these are our three different versions of the law of cosines. Any of them work. We just have the different versions written out depending on how our labels match what's given to us. So let's look at number 1. If you notice in part A, I do not have an angle and opposite side pair. So I can't use the law of sines, which means I need to use the law of cosines. I'm going to label this A, B, and C. Across from big A is little a, across from big B is little b, and across from big C is little c. Notice how they give me the angle A, which means I want to use the law of cosines that has angle A in it, which is our last one. So because this equation uses angle A, this is the one I chose, and now I'm going to plug in all my values. Little a is x, little b is 20, little c is 14, and angle A is 60. Notice how x is very close to being by itself. I just have to get rid of the square. Well, in order to get rid of a square, all we have to do is square root. And you're actually able to plug this all into a calculator. So if you type in the square root of 20 squared plus 14 squared minus 2, and you can even do parentheses in the calculator. Parentheses 20, parentheses 14, and then the cosine of 60. You should get 17.78 when you round to 2 decimal places. If you didn't get 17.78, please come see me in class so that we can practice plugging this into the calculator together. Let's try another one. I'm going to go ahead and put in my labels. And notice how this time I have angle B. So I am going to look for the equation that includes angle B. And that would be the second one. So I'm going to go ahead and write b squared is equal to a squared plus c squared minus 2 times a times c, cosine of angle B. Now that I've chosen my equation, I'm going to go ahead and plug in all my values. So I have x squared equals 7 squared plus 6 squared minus 2 times 7 times 6, cosine of 120 degrees. And once again, to get rid of the squared, all I have to do is square root both sides. And if I plug that all into a calculator, I should get 11.27. Let's try one more. And this time, notice how I'm missing an angle. So we're going to find out how the law of cosines works when we need to find an angle. I'm going to start by labeling my letters. I have little d, little e, and little f. And I know that our law of cosines are written with A, B, C, but the same idea applies. Because I'm looking for angle D, I need to end with the cosine of D, and I need to start with little d squared. The rest of the equation uses the remaining two sides. So e squared plus f squared minus 2 times e times f. If it makes you feel better though, you are more than welcome to cross off these labels and write A, B, and C if that would make you feel more comfortable. But hopefully you see the pattern of how the equation is written, and you could do it with any labels that they give you. I'm now going to go ahead and plug in all my values. So little d is 21, little e is 11, little f is 19, and we are missing angle D. This problem is a little different than the other two that we've done because our missing variable is on the right side and it's not by itself. If you've noticed in the other two, the x was already practically by itself, that all we had to do was square root both sides. But for this problem, we have a lot more work on our hands in order to get d by itself. I'm going to start by simplifying. So 21 squared is 441, 11 squared is 121, 19 squared is 361, 2 times 11 times 19 is 418, and 121 plus 361 is 482. Now please be careful. Notice how 418 is attached to the cosine of D, but 482 does not have a cosine of D attached to it, which means those two numbers are not like terms. Because 482 doesn't have a cosine of D, we cannot subtract 418 from it. So what I'm going to do is I'm going to subtract 482 to the other side. And this will give me negative 41 equals negative 418. And because the negative 418 is being multiplied to the cosine of D, I have to divide. Two negatives will cancel out to be a positive. So I'm left with the cosine of angle D is equal to 41 over 418. And now I have to get rid of cosine. Remember, we cancel out trig functions by using its inverse. So I'm going to take the inverse cosine of both sides. And when I plug that into my calculator, I'll get that angle D is 84 degrees. So if you look at the pictures, we use law of cosines when we know all three sides and we're looking for a missing angle, or we have two sides and an angle in between them. I like to determine if I can use law of sines first because that's my favorite method, and if I don't have enough info for law of sines, then I'll regroup and use law of cosines instead. So please let me know if you have any questions about the law of cosines or plugging it into your calculator, and I will see you in class.